Hello, welcome back to Algebra. The title of this lesson is called Multiplying and Dividing Rational Expressions. This is part 1 of 2. So in the last couple of lessons, we've talked about rational expressions and graphing rational functions. We're still going to be dealing with rational expressions, but here we're going to be learning how to manipulate them a little bit more. As hopefully by now you can see how important these things are. Rational expressions, rational functions pop up in all branches of science and engineering. I mean, everything from the theory of relativity to atomic theory to chemistry, they all have these rational functions, rational expressions in them. So now we're going to learn how to multiply and divide these guys. Now we're doing multiplication and division of rational expressions first before addition and subtraction because, believe it or not, multiplying and dividing these things is actually easier than adding and subtracting them. And so you'll see why as we go along. So we'll start with the multiplying and dividing, then in the next lesson or a few lessons we'll do adding and subtracting these rational expressions. Now remember back when we started this algebra journey, I told you one of the most important things that you can learn is fractions. Not only what a fraction is, but how to add fractions, how to multiply fractions, how to divide fractions. And I've done a lot of review in fractions along the way, and that's because people have a problem with this rational expression business. Mostly, the students that have problems with it mostly have problems because they were never really good at adding fractions or dividing fractions or multiplying fractions. And so that's why we did that review. So if you can remember that stuff, remember how to deal with regular fractions, then this stuff will be very, very simple. So to get you on the right path, I'm going to do a quick mini review here. How do you do something like this? 1/2 multiplied by 3/4. How do you do that? Well, when we multiply fractions, we do not need to find any kind of common denominator. We don't need to do that. That's for adding and subtracting fractions. To multiply them, all you do is you take the numerators and multiply them. 1 times 3 is 3, and 2 times 4, you multiply the denominators. 2 times 4 is 8. And then you try to simplify the final answer. In this case, it's already simplified. So that's how you multiply fractions. Multiply the numerators, multiply the denominators. So in a minute, when I give you rational functions or rational expressions, which are just giant fractions, to multiply them, you just multiply the tops, multiply the bottoms. It's the same rules of regular fractions you already knew. Now moving along, how do you divide fractions? What if you had 1/2 divided by 3/4? How do you do that? And if you remember back when we talked about regular fractions, we said the way you do it is you take the first thing, you leave it alone, but you change this division into multiplication, and when you do that, you take the second item and you flip it upside down, make it a reciprocal 4/3. So this division turns into multiplication, but when you do that, you have to take the reciprocal of the thing here, and now you know how to multiply fractions because we just reviewed it here. 1 times 4 is 4, and 2 times 3 is 6. Now you can simplify 4/6 by dividing 2 on the top, 2 on the bottom. That's fine. We'll do the simplification. You already know how to simplify fractions. But the point here is for algebra, when you're multiplying rational functions, you multiply the tops, multiply the bottoms. If you're dividing these rational functions, then you have to change it to multiplication and flip it upside down, just like we do for numbers. No difference. So now that we have that in the back of our mind, let's go on and try to tackle some algebra. Before we actually get into the meat of algebra, let's do something kind of intermediate here. What if we have -10 21st, that's a fraction, and we're going to divide it by 15 28ths. Of course, there's no x's and y's in this, but we're going to crawl before we can walk. How do we do it? Well, we take the first item, we leave it alone, the first fraction. We change this division to multiplication, and we take the second fraction and flip it over, 28 over 15, right? That's what we do. And then after this, you can multiply the tops, multiply the bottoms. But there's one more thing here that this is such a simple problem, you can't really illustrate it. But of course, you can multiply the tops, get an answer, multiply the bottoms, get an answer, simplify the result. But now you know when you have fractions multiplied, even algebraic fractions in algebra, if you can figure out a way to cross-cancel, like if you can find a common factor to both of these or a common factor to both of these, then you're allowed to do some cancellations ahead of time before you do the multiplication. Or if you'd like, you can just multiply it all out and get the answer and simplify the answer. But you need to really be looking for things you can cancel ahead of time because when we get into our algebraic expressions, they're going to get really, really, really big. So you want to cancel what you can ahead of time so you're not writing an enormous expression and then simplifying the answer. So to make progress here, what I'm going to do is I'm going to rewrite what I have here because I'm going to mark it up. It'll be -10 21 multiplied by 28 over 15. And then we start looking, okay, what can we divide 21 and 28 by to get an even number. We can divide both of those by 7. So 28 divided by 7 is 4. 21 divided by the same thing, 7, is 3. So this now changes. Where there's a 3 here and a 4 here, 4/15 times -10/3 is exactly the same as what we have here. You'll get the same answer, all right? Because basically we're cross-simplifying, right? Then we have 10 and 15. Of course, we can divide by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. Notice I still have this negative here. I didn't touch the negative. I just looked at the numbers. Divide by 5, divide by 5, right? And then now I have much simpler numbers. So then what I'm going to do is multiply the tops and multiply the bottoms. This is a -2 times 4, which would be -8. And this would be 3 times 3, which is 9. So the answer is -8/9. Circle that in your answer. You can't simplify it anymore. You can't divide top and bottom by something common, so you're done. Now I want to stress to you that you don't have to do this step, of course. You could take this, -10, multiplied by the 28, will give you -280 on the top, right? And then 21 times 15, I confess I haven't actually multiplied that out, but you can multiply that out and you'll get a denominator. So you'll have -200 and 280 on, maybe I said 210, I'm sorry. 10 times 2 times 20 is 280. So -280 on the top. You'll have whatever number you get on the bottom by multiplying. Then you'll have a giant fraction that you have to simplify. And when you simplify it, you will get -8/9. But instead of multiplying ahead of time and then simplifying the answer, what we chose to do is start simplifying even before we do the multiplication. So these can be simplified by dividing by 5. These can be simplified by dividing by 7. Then we have much smaller numbers to deal with, and we can get the answer without getting a calculator out, because we don't want to use calculators, right? Now, that process is useful for regular fractions, but crucial for rational expressions, and you'll see as we go. Let's take a look at our first real problem in rational expressions. What if we have 5x to the 3rd power over -3? That's going to be multiplied by -6 10x squared. Now, again, this is a fraction. It's a fraction times a fraction. Just because it says rational expression, that's just another word for a fraction that has algebraic stuff in it, right? So we could do it the same way. I could take the 5x cubed, I could multiply by -6, I'd get the numerator of the answer. I could take this times this, and I would get -30x squared for the denominator of the answer. And you would get exactly the same. Once you simplify all that, you'll get exactly the same thing. In fact, we might do it that way just to show you one time that you get the same thing. But you really need to be canceling ahead of time. So because I'm going to mark it up, I'm going to write it again. 5x cubed over -3 multiplied by -6 over 10x squared. So now we start trying to figure out if we can simplify the numbers. 5 and 10, 5 divided by 5 is 1, 10 divided by 5 is 2. But then I also have x cubed and I have an x squared. If they were right on top of each other, you could of course cancel 2 of them, because both of those x's would then cancel with this. I could put a 1 here to let you know that there's 1 left, but when I strike through the exponent, I know I have x to the 1st power left, so I'm going to leave it like this. So I've marked up all of that. Now I'm going to switch colors to mark up the other side. The 3 divided by 3 can be 1, and the 6 divided by 3 can be 2. Of course, I'm going to leave the negatives there for now. I don't have to touch that right now. Okay, so let's go ahead and continue. On this side, I have 1x, and then I have -2. So x times -2, when I multiply the tops, will be -2x. Right? Let me just double check myself. -2x. Okay, and then on the bottom, what I'm going to have is, I have a negative, this is a 1, and then I have over here, the only thing left, I've already struck through everything, I only have a 2, so -1 times 2 is -2, like this. And then when I simplify this, the -2 can cancel with the -2, so I'm just going to have x as the final answer, and that is the final answer. So this entire rational functions that are multiplied, simplified, and all that, end up giving you a very, very simple answer. Now, just for giggles, I'm not going to do this every time, but just for this one time, let's go ahead and do this the full-blown way. Let's multiply the original problem out. 5 times -6 is -30, x cubed. On the bottom, -3 times 10 is -30, x squared. You can see right away the 30s are going to cancel. You can see right away these signs are going to divide away. The x squared is going to cancel. I'm only going to have one x left, so I'm just going to end up having x for the final answer. So you can always get the answer when multiplying these rational expressions, just doing it like a fraction. Multiply the tops, multiply the bottoms, simplify. But this is a simple problem. I'm going to give you a problem in a little bit that would be quite a bit of work to multiply it all out first, then simplify. So I want you to get in the habit of trying to cross-simplify ahead of time, because it's a very important skill. All right, so let's kind of increase the complexity a little bit as we go here. What if we have 8 times t squared over 3, and we're going to divide that by another rational function, 2 times t over 9, like this. Now, the first thing you do is you realize division can be changed to multiplication. So you have 8t squared over 3. We change the division to multiplication, but then we have to flip the second fraction over, 9 over 2t. Then we're going to start cross-canceling, but I don't want to mark up what I've already written here because I want you to be able to see the whole step of everything. So I'm going to rewrite everything again. I know that's a pain, but I really don't want to mark up what I write down because then you won't be able to see what I'm doing. Like if you go back and review it, you need to be able to see what I wrote down pristinely. So then we start cross-canceling. Look here, we have a 3 and a 9. 3 divided by 3 is 1. 9 divided by 3 is 3. We have an 8 and a 2. 2 divided by 2 is 1. 8 divided by 2 is 4. And then we have a t squared and a t. We can divide that by t, and we can cancel it, leaving only one t remaining. So then, we'll get closer to the final answer here. Over here we have a 4t times 3. 4 times 3 is 12, times t. On the bottom we'll have 1 times, there's nothing left here, so it's just going to be 1. So you can just write it as 12t. Let me double check myself. 12t is the final answer. That's correct. Again, I could have multiplied this 8 times 9, then 2 times 3, and then the t's would cancel, the numerator and denominator would cancel, and I would end up with the 12t exactly the same. But as we get farther and farther along, especially if I add more terms to this, it's going to be way easier to cancel ahead of time. That's why we're doing it here. Next problem. What if we have x squared over 4 multiplied by, parentheses, x times y over 6 raised to the negative 1 power times 2y squared over x. I told you this would get a little more complicated a little bit rapidly. So here we have 3 multiplications, and one of them is actually weird because it's something raised to the negative 1. So you have to take it one step at a time. First, forget about this, focus on this. So what you have here is you have x squared over 4. This, remember, to the negative 1 just means that it's 1 over x, y over 6 to the first power. We just move it to the denominator, make it a first power, and then we're not going to touch anything else. 2y squared over x. All right, so we have 1 divided by this, but you now know that division can be changed to multiplication. So we're going to change it again. X squared 4 times. This is going to be 1 changes to multiplication, flip the bottom over, which is effectively going to be 6 over xy. And then the last term is going to be 2y squared over x. Make sure you understand what's going on here. What this middle term really means is you have the numerator of 1, which can be written as 1 over 1. The division can be changed to multiplication, and then the bottom has to be flipped to multiply it. And so what you're going to get is 6 over xy. So that's what we have written for this term. 6 over xy is the same thing as xy over 6 raised to the negative 1 power. Another way to think of it, to be honest with you, is when you have negative 1 here with a fraction, just flip it over. I mean, you can think of it either way. Do it this way or just flip it over in your mind. That's fine too. Okay, then now we could of course multiply through everything. There's no problem with that. It's just that there's lots of places to simplify things. So what I'd rather do ahead of time is, well, again, there's different ways to do it. I could start canceling some of these x's here, or I could just multiply through. In this case, just to make it a little bit different, I'll go ahead and multiply through. We have 6 times 2 is going to give you 12. X squared times y squared will give you x squared y squared. On the bottom, 4, that's the only number. And then x times x is x squared, and then I have y. And now you can see I can cancel quite readily. Let me rewrite it so I don't mark over that. X squared y squared over 4x squared y. And then I can divide by 4. When I divide the top by 4, I'll get 3. Of course, I divide the bottom by 4, I get 1. The x squared completely cancels with the x squared. One of these y's cancels with only one of those y's, leaving 1 left over. So what I have, 3 times the y. And on the bottom, I have nothing at all. So it's over 1. So I can basically just erase it and make it 3y. That's the final answer. So again, in this case, I kind of broke my own little rule just because it doesn't, this problem is so simple it doesn't matter. I just multiplied the tops, multiplied the bottoms, and simplified. But I could have, from this point, started simplifying ahead of time. Like for instance, I could have said, well, 2 divided by 2 is 1, 4 divided by 2 is 2. And then I could have said, x, one of these x's can cancel with one of these x's. And then I could have said one of these y's cancels with one of these. I could have marked all this up and then done the multiplication. I would get exactly the same thing. All right. So now we're going to move over to slightly more complicated problems. Are they crazy? No, not yet. I've got a couple of harder problems on the last page. But for now, we're not going to get to crazy land yet. We're just going to move up just a notch in the complexity. 4 times r times s squared divided by 45. Okay, that's a rational expression. We're going to divide that by another rational expression, 8s over 27r. And we'll then divide that by 9rs over 10. So my advice is anytime you have divisions, first change them to multiplications, flip everything over, and then figure out after you have it all in terms of multiplication what to do next. So over here we'll have the 4rs squared, 45. Change this to multiplication, flip the second one over, 27r over 8s. In the same step, we can then change this one to multiplication, but then flip the second one over. 10 over 9rs. 10 over 9rs. Now this is a good example of how I'm doing a problem slightly differently depending on how it works out. In this problem, I had 3 things multiplied together. In this problem, I also have 3 things multiplied together. Here, I chose just to multiply the tops, multiply the bottoms, simplify, because the numbers were very simple. Here, if I multiply the tops, I'll have 4 times 27 times 10. That's a big number. And then I'll have 45 times 8 times 9. That's a big number. And then I'll have all the variables too. It'll be kind of difficult. So I'm not going to multiply first. I'm going to try to simplify first. So let me over here just rewrite exactly what I have. 4 times rs squared over 45. And that's multiplied by 27r over 8s. And then that's also multiplied by 10 over 9rs. 10 over 9rs. Let me just catch up and make sure I've got everything correct so far. Let me go ahead and try to simplify this. What can we do? There's lots of different choices. I have over here, I have a 4 and a 8. Now, by the way, when you simplify these guys, when you cross simplify, I could cancel this with, if I had something over here, it doesn't have to be to the next door fraction. It could be, since they're all multiplied together. I mean, when you think about it, when they're all multiplied together, everything's on top and on bottom. So I can cancel anything as long as it's in the top and the bottom, any which way, any combination, as long as it's on the top and on the bottom. So here I have 4 divided by 4 is 1, 8 divided by 4 is 2, right? And then I have, for 27 and a 9, 9 divided by 9 is 1, 27 divided by 9 is 3. Okay, and then I have other things I can do as well. I have an r here, I'm going to cancel through there. I have a single r down there, I can cancel there, right? I have an s here that I can cancel with one of these s's. So I can cancel this guy and just leave one s there. And that's far enough. I could actually go farther, but I'm just going to leave it like this for now. And let's go ahead and cruise along here. Don't have any numbers here, just have an s times a 3 times an r times a 10. So 10 times 3 is 30. So what I'll have is 30, right? And then r times s, rs over. Over here I have 45 times 2 is 90. And then I only have an s left over. So I have 90 s. Okay, so let me rewrite this again. 30 rs over 90 s, because I don't like to mark things up. So I can divide the 30 out, right? 30 divided by 30 is 1, 90 divided by 30 is 3. And then s divided by s can cancel out. And so what I will have then, I'll have an r on the top, and I'll have a 3 on the bottom. So the answer is r over 3. That's the final answer. And to be 100% truthful, you know, I solved these problems ahead of time, and I know what I did, right? But when I'm solving it for you, I'm not just copying it because I don't want to be like a robot. I want to show you my thought process. And actually, when I look at what I did, it's very slightly different than what I did here. I don't want to go through it, but I'm just noticing that I actually got there a slightly different way. What happened is when I started simplifying here, I chose like this, and I chose like this, and so on to simplify, but when I actually did it the first time, I chose slightly different things. Like I did this S and this S. Well, I may have chosen in another alternate universe this S with this or something else. There are other choices. The 8 and the 10, for instance. Originally, I had an 8 and a 10. I could divide those by 2, right? Instead of going the direction that I effectively went in the problem. So I think that's probably something like what I did here. But at the end of the day, I got down to exactly the same answer. So when you're simplifying and multiplying these rational expressions, you have multiple different ways to go. And you will always get the same answer as long as you're doing the correct steps and rules and following them along the path. Now we have 2 more. These are a little bit more complex because rational expressions can look a lot more complex than what we've done so far. So let's do a couple like that. It's x times x minus 1 divided by x minus 2 squared. That's rational expression number 1. I'm going to divide that by another rational expression, x minus 1 squared, and then on the bottom will be x minus 2. All right? So I have 2 rational expressions there, and they're divided. So the first thing is you want to change this to multiplication and flip over the next guy. So what I'll have, a lot of copying. I know it's not fun, but you need to copy it over so you know what you're doing. X minus 2 squared. All right, so I've rewritten the first guy, and I changed this to multiplication. I flip over the second one. So I'll have x minus 2 on the top. On the bottom, I'll have x minus 1, but that's squared from here. And then I notice I'm going to have some cancellations. I see some similar terms, so in order to cancel them, I'm going to rewrite everything again so that I don't disrupt what I have. X minus 2, that'll be squared, times, I'll put parentheses x minus 2 just to group it, because it doesn't matter if there's parentheses there or not, x minus 1 squared. So then I see right away, what do I have? Well, x minus 2 will cancel with one of these x minus 2, so I'm going to strike through the exponent, leaving 1 behind. This x minus 1 term will cancel with one of these, leaving 1 behind. And so I'll have x on the top, nothing else. And on the bottom, I'll have x minus 2 times x minus 1. So I'll write it as x minus 1, x minus 2. And that's the final answer. X over x minus 1 times x minus 2. So again, change division to multiplication, flip things over, cancel as appropriate. In this case, we didn't need to do that much because once we did the cancellation, what fell out basically is fully simplified. All right, the next problem will have a touch more work involved once we do the final cancellations. The next problem is 4 times u squared minus 1 over u squared minus 4. But that's a giant rational expression multiplied by u minus 2 divided by 2 times u minus 1. So we don't have any division, so we don't need to change it and multiply, but we do have things that we need to try to cancel. Now, first thing you do when you look at this is you say, what can I cancel? Right? Can I cancel this with this? No. Can I cancel this with this? No. And then you say, okay, well, I'll just multiply the tops and multiply the bottoms. But what's going to end up happening is you're going to have this times this. You're going to have a lot of terms cross-multiplied with additions and subtractions. Same thing here. You're going to have a lot of terms. The biggest term will be a u cubed because you'll be multiplying u times u squared. Same thing here. So you'll get a very large polynomial in the top with u cubes in it, and you'll have a large polynomial in the bottom with u cubes. And I can just tell you from experience that when you have a big polynomial on the top and the bottom, you're not going to be able to cancel it. The only way to really cancel things is if you have it broken up into factored form, and you can cancel the terms in the factored form. The only problem is in this problem, it doesn't look like there's anything that can be canceled. So if you're given a problem where it looks like you have nowhere to go, then you must make the assumption that you're just not seeing what to do. So there has to be a way to factor some of these things that you might not be immediately aware of when you stare at it for the first time. So you need to think back, what kinds of things can I be looking for to factor things? Like in this case, it was a lot easier, the previous problem, because all of the factored forms were already there. But there has to be a way to factor some of these things in order to cancel things, otherwise the problem goes nowhere. Obviously, I can't factor these anymore because u minus 2 and 2u minus 1, there's no squares anywhere. So I can't really factor that at all. But there's lots of squares here. And then you say, wait a minute, this is u squared minus 4, but 4 can be written as 2 squared. So that's u squared minus 2 squared. That's a difference of two squares. So I can factor a difference of two squares. And then you say, maybe I can do the same thing upstairs. How can I rewrite the numerator here? I can write that to try to make it factorable as 2u squared minus 1 squared. This is the same thing as this because the square would be applied to the 2, giving 4, applied to the u, giving u squared minus 1 squared. This is also a difference of 2 squared, and this, or a difference of 2 squares, and this can be written like this, which is the difference of 2 squares. This stuff over here, u minus 2 and 2u minus 1, you can't do anything with that. So how do we proceed? Difference of 2 squares, we should know by now, is going to be 2u plus 1 times 2u minus 1. You just take what's in here and what's in here and you add them and subtract them like this. Here, same thing. You have u plus 2, u minus 2. But then you're multiplying by u minus 2 over 2u minus 1. Look at that. I have a u minus 2, a u minus 2, a 2u minus 1, and a 2u minus 1. So I'm going to break my own little rule here this one time because I don't want to rewrite all this stuff again. This will cancel with this. And this term will cancel with this one, right? So what are you going to have left? You're going to have 2u plus 1 divided by, there's nothing else left. You'll have a u plus 2. 2u plus 1, u plus 2. This is the final factored form. The trick to this one, it's not really a trick, but is you have to logically go through it. Look, I can't factor that at all, but these have squares. So even though they don't look so easy, there has to be a way to factor them. And the first thing you should think of, can I do difference of 2 squares? Once you get to that point, then you can realize how to rewrite them to get them to cancel and get the answer. So that's my advice to you. So here we've introduced the concept of multiplying and dividing rational expressions. We started from baby problems. The very first problem we did was just a fraction with numbers, right? And then we gradually increase the complexity to more complicated problems. I want you to do every one of these problems yourself. Grab a piece of paper, go through the lesson again, write them down, solve them. Then follow me on to the next lesson. We will wrap up this concept with even more difficult problems, but the same concepts will apply. We'll be multiplying and dividing rational expressions in algebra.